Hello everyone, let's welcome to my channel. So here we are with new question of ordinary differential equation. So let f of x comma y equal to y square plus 4xy plus 3x square plus x cube. Then they have given you the function and we have to check this function is going to be minimum at 0 0 when x value is 0 and y value is 0, whether this given function is going to be minimum or it going to be saddle point or it is maximum point of the f, or at the point 2 comma 2 by 3 comma minus 4 by 3, is it a maximum point of your f? We have to check it. So whenever the function is given to you and if you want to check whether it is going to have a minimum point, saddle point or maximum point, we are going to use the second order derivative test. Okay, you have to use the second order derivative test, that is nothing but d is equal to, you have to take the partial derivative of f 2 times x with respect to x only, then I have to take the partial derivative of y 2 times with respect to y, then minus f, you have to take the partial derivative of f with respect to x, then we have to take the partial derivative with respect to y, then we have to take the square of that. If this d, this is equation number 1, if this d became greater than 0 and if f of fxx is greater than 0, then you are going to have a minimum. Okay, whenever the d is greater than 0 and the function, the derivative with respect to x is also positive, then it is going to have a minimum at point. Okay, then we have to check whether this d is, if this second is, if this d is positive and your f of x is negative, then you are going to have a maximum. And if this d is less than 0, and then it is going to have a saddle point. So function is given to you, f of x comma equal to y square plus 4xy plus 3x square plus x cube. So what I have to do, I have to find out the f of xx. So here I have to take the partial derivative of f with respect to x, it will become 4y. The y square will be treated as a constant. If I take the partial derivative with respect to x, it will become 0. So this will become 4y, and 3x square is there. If I take the partial derivative of 3x square with respect to x, it will become 6x. If I take the partial derivative of your x cube, it will become 3x square. But I have to take the second order. So again I have to take the partial derivative of this equation with respect to x. So if this y is going to be treated as a constant, so 6x will become 6 and 3x square will become 6x. So 6, take out the 6 common, what you are going to get? 1 plus x. So here I got the value of xx here as a 6 into 1 plus x. Now what I have to calculate? Fyy. So here take the partial derivative of your f with respect to y, it will become 2y plus 4x. Then again take the partial derivative of this equation with respect to y, so it will become 2 plus 0 it equal to 2. So now take the partial derivative of your fx. Here I want fxy. It means first of all I have to take the partial derivative of your f with respect to x, then y. So with respect to x we got this fx is nothing but equal to 4y plus 6x plus 3x square. Then take the derivative of this equation with respect to y. So the x will be treated as a constant, x is also treated as a constant. So if I take the partial derivative of this with respect to y, we are going to get as a 4. Now substitute these all values in this equation. What is the fxx? Its value is 6 into 1 plus x. And what is the value of your fyy? Its value is 2 minus 4 square. Minus 4 square will become 16. 12 into 1 plus x minus 16. But I have to check at which point. First of all, we have to check at option A, B, C is based on 0, 0. Just substitute the x value. We have to check this d is going to be positive or negative at the point 0, 0. So x value is 0 or y value is also 0. Substitute x value as 0. So d equal to 12, 1 plus 0 minus 16. 12 minus 16 it will become minus 4. Minus 4 is less than 0. Whenever minus 4 is less than 0, so which option is going to be correct? Saddle point. You are going to get the saddle point, not a maximum point. So which option is going to be correct? At the origin you are going to get the saddle point. That's why B option is going to be correct.